Welcome to the General Structures 2 and Lateral Forces lesson number 1 quiz. Question number 1. And it asks, which of the following structural systems consists of a flat element acting together with a deep element to resist bending? So, I'm guessing that we have something like this. It says a flat working together with a deep. Something like that. To resist bending. All right. And our answers are 1, 2, whoops, that's not 2. And I'm just going to go over what these are and why or why not they will work. And 4. All right. Okay, 1 is composite beam. And the answer is yes. What a composite beam will be, this could either be steel or concrete, and usually it's going to be steel, because when you say composite, if it's concrete, why don't you just make it a T, which might be one of our other answers, and it looks like it is. But anyways, a composite beam is you'll have like a steel I-beam or a plate girder or some type of steel section, and then you'll have these little studs every so often going along the top of that top flange. And what that does is that engages this concrete, and this makes it one composite member as opposed to two of them. So these act together. It does not allow it for it to slide, and therefore it's a composite beam. So composite beam is a correct yes. And how does that help in bending? Well, when you look at this and you say, okay, well, what type of bending would that work well with? And my answer would be a positive moment. And hopefully that makes sense to you. So if you think about it, positive moment is, I always like to think of simple spans. So simple span will give you a positive moment. If you put your load, it will bend down like that. It will smile. Negative moment situation is you can have a continuous beam, and it's goes down like that. It has to come back up at some point, and then it has to go back down. And what this over this middle part, if you remember your moment diagrams, you'll remember that the moment goes positive. I'm going to do it in different colors so it doesn't get too confusing here. But it goes positive, and then it goes negative, and you go negative to positive, and then it goes back to 0. So that's positive region, negative region, and this is for a uniform distributed loaded beam. And this is all positive, something like that. Obviously this is for a uniform load, and this is not a uniform load that I'm showing right here. So just pretend like you don't see that. Alright, so that's all positive moment. That's positive moment, and then over the middle supports negative moment and positive moment. And what is it doing in positive moment? If you think about it, what is the... I'm going to change colors again. What is this doing? If you have a beam, what is happening to that top flange? What is happening to the bottom section? And my answer would be, if you just cut it, what would it want to do? Well, this would want to go like this. And the top is squishing together. So the top's in compression and the bottom's in tension. And we've been over that through the first set of videos. But when you're doing that, like if you look at a pencil, you push the pencil, you're trying to snap the pencil. The part that you're pushing is in compression, and the part that you're pushing on the opposite side is going to be in tension. So what's good in tension? We know that concrete is good in compression. So this section, the top, is all going to be in compression. And look how much you have of it. That's a huge width for concrete. That B is huge. So that's good. That's going to help you out. And then in tension, you can work this entire bottom flange. And steel is good in tension. So you're going to have a kind of internal moment that looks like so, where this is tension, this is compression, and this long web is just connecting the two. So that is a composite beam, and I know I took a long time to explain that, and hopefully you understand what a composite beam is and why it does what it does. I should probably run through these answers a little bit quicker as opposed to explaining it like that. Anyways, a flat slab. If you go back and look at what a flat slab is, I'm not going to draw it, but if you go on page 19, you can see that a flat slab will not really help you in moment. So it's more to, it's, in other words, it's not an answer. If I need to explain that to you, it's just not the answer. And then for the same reason, the flat plate. And the flat plate and the flat slab are pretty much the same, except the flat slab has a little bit extra to resist shear. So that's not a good answer either. And then 4 is, we've already kind of explained that, but a T-beam. A T-beam is pretty much the same thing as a composite beam, except it's all concrete and it looks like a T. So instead of making this, and in this case, okay, let's say your compression blocks is right here. Usually when you do a T-beam or a composite beam, you want your compression block to be entirely in that slab. And then on the other side, your reinforcing is going to resist the tension. So you'll have tension and then your compression. All right. I believe that is enough. So that's T-beam. And that is also, for the same reason, it has a long, for instance, let's say, it has a long moment arm, this internal moment arm right here, which when we get into concrete, you'll learn it's called JD. And you could look at it some other way. JD kind of equals, not kind of, but it does, D minus A over 2, which is another, you have to understand what A is, and you're going to have to understand what C is, and I'm not going to get into that right now, and I probably shouldn't even said that, so don't worry. But let's call it a moment arm. Ignore that. This is a moment arm, and the longer that is, the better moment it is, because sum that moment about this point or this point. If you think about it, C, when you cut stuff, C has to equal T. C equals T because of equilibrium. If you're gonna push that way, you have to resist it that way. Those have to be equal to go with equilibrium, and then when you take a look at this, you can figure out what the internal moment is by taking this distance. Let's call it JD. Let's call this distance JD. Oh, I don't like that. Let's just say it's a moment arm equals moment arm. I'll just call it moment arm. So C times the moment arm. The bigger this moment arm is, the bigger your moment's going to be. Or you could change C, but that means you'd have to make a bigger compression block. Or you could, this also equals T times moment arm. And hopefully it makes sense in here. To get a larger T actually, you'd have to increase your steel, and T actually equals ASFY, which AS is your area of steel, and FY equals your yield strength of your steel, which is typically 60 KSI. So I hope I didn't try to confuse you too much, but you can ignore all this stuff. The fact is, what this T-beam and the composite beam does is it gives you a larger moment arm. And instead of, let's say you use the same amount of concrete and just do a slab. Well, this slab and all this concrete right here will only fill up that much. So now you have a slab that looks like this. Look what that moment arm is. Let's put reinforcing in there. That new moment arm is only right here, which is about half, which is going to kill you. And you'll see that later, and I'm not going to go into it anymore. I think I've decently explained what with a composite beam and a T-beam, you're using the materials to your advantage. And the composite beam, you're using that compression concrete from the slab as compression, and you're using your I-beam, your steel I-beam flange and tension, and you're using that slim piece of metal web, relatively slim. I mean, 3/8 you can get around 1/2 inch. You don't usually don't see those bigger than 1 inch, even on the very large bridges or whatnot. And you're using that, and you're getting that moment arm way out there as far as you can, so you end up having a very large moment arm. And same thing for your composite beam and your T-beam. All right, I beat it like a dead horse. I hope that explains why it helps to resist bending. It makes a bigger eye